Hello guys, placements channel. So today we are going to discuss the next part, that is the pre-order iterative traversal. So if you want to understand this pre-order and all these things, you have to watch the previous video, that is the pre-order recursive traversal. So here in this, I have explained few of the tricks in the in order iterative traversal video. So it is better that if you follow my playlist in an order, so that you get in-depth knowledge regarding the concepts, and you'll learn the tricks along with the videos. So here the pre-order iterative traversal. So if you listen the word iterative, so in that particular situation, in your mind the stack must come. So this is one of the trick. So what you should remember, now I am going to explain how this how the iterative process works. So here 3 is present, and then here 4 is present. So and here 5 is present. So first thing, so here the root node is going to point on the root node of the tree. So here the root pointer is pointing on 1. So first thing, so let us check if the root is not null. In that situation, push this particular element into the stack. So I have pushed the element 1 into the stack. At the same time, print that particular element here, and then move on to the left subtree. Now after completing this step, so we'll move on to 2. So now the root is pointing on 2. So again this root is not null, hence push the 2 inside the stack and then print the 2 here, and then move to the left side of the move to the left subtree. Now the root will point here. So this root is not null, it is pointing on 3, hence push the 3 onto the stack and then print that particular 3 here, and then move to the left side. But after moving to the left side, we find that this particular root has become null in this case, because here no child is present and hence it is null. In this situation, what we have to do, we have to pop the element out of the stack. So this particular thing can be easily understood if you have watched the in order iterative traversal video. So I have popped the element 3 out of the stack. Now the root is going to point on this particular 3. That means here we are back traversing. So here we are back traversing. So hence this root has been back traversed to 3 now. And after back traversing to the tree, what we will do, so we will traverse to the right part of the subtree. Now the root is present here, but this is also null in this case. So then what we will do, so we will again go to the stack and pop out the top of the stack, that is 2. Now the root is going to point on 2. So hence we have so backtraced the thing, so and hence the root is going to point on 2 here, and after pointing on to 2, so we will move to the right side, then the root is going to point on 4. So these 2 elements has been popped out. So now the 4 will so now the 4 is going to be the top of the stack, and then we'll again so move on to the left child, so it is null, and again we'll pop this 4 out of the stack. Now R is going to point on the 4 again, and then we'll move on to the so right child. So this right child is also null, so hence what we will do, so this has been popped out. So now what we will do, so we will pop this one out of the stack, and this root is going to pop on this root is going to point on this one, and later we will move to the right side. So hence the root is present here, that is root is pointing on the 5 here, then the top of the stack will be 5, and we'll, okay, so here when we push this 4 onto the stack, we'll, okay, so print at the same time. So now I am going to now as I am pointing on the 5, I am printing this 5 here. Okay, now I am going to traverse to the left part. It is null, so hence I am going to pop this 5 out of the stack. Okay, and I have back traversed, and again I am going to, okay, traverse to the right, but in this case the stack has become empty, so hence I am going to terminate the loop and I am going to return the pre-order vector. So now let us see how this works. Okay, so first I require a vector, so which is going to store the pre-order, okay, path, that is the traversal thing. So now I require a stack. In C++ I am going to use the STL. So tree node star s. Okay, so I have said until the root is not empty, that is until the root is not null, or the stack is not empty, that means s.empty is false, that means the stack is not empty, I am going to continue this loop. If the root is not null, I have explained, if the root is not null in this situation, okay, if the root is not null, I have to push this element into the stack. Okay, I am going to push this root into the stack, and after pushing that I have to print this particular element, or else I have to push that element into the vector. Okay, I am going to push the element, that means push the value of that root into the pre-order, and after pushing the root into the stack and pushing the root's value into the vector, I have to traverse to the left of the subtree. That means I have, okay, pushed this one on into the stack, and then I have printed and I have moved to the left of the subtree. It is cleared. So if the root is null in that particular situation, I am going to take the reference of the top of the stack into my root. That means so here initially, suppose if 5 is present, first I must store this 5 into this root. That means I have to make my root to point on that particular node, then I should pop it from the stack. Okay, I am going to pop this out of the stack. So here I am using the STL completely. If you don't know STL, then you can comment in the chat box, that is the comment section. So I am going to make a in-depth video regarding the STL. And after, okay, so popping, I have to traverse the right part. So this is cleared, and then I am going to return the, okay, so pre-order vector. Okay, so let's run the code. Yeah, it's working fine. So now let us submit the code. Yeah, it's working perfectly fine. So the time complexity will be O of n, because each node is going to be visited at max 2 times, that is 1 time while traversing and 1 time while back tracing. And the space complexity will be O of n, that is O of log n in the best case. In the worst case it will be O of n. So why? Because here we are using the stack and we are going to traverse the tree up to all the levels, like so here we were present on 1, then 2, then 3. So this is the height of the tree, and after that we are going to pop the element. That means on the average case the space will be O of log n, but in the worst case, that means in the case of skew trees, it will be O of n. So please, I have explained all the things which are necessary completely. So thanks a lot, and please subscribe to my channel.